Hello everybody, we're getting ready to do 5.1, part 2 of pre-calculus analytic trigonometry. And if you need materials, email me here for those. Note-taking guides, PowerPoints, and class worksheets, email me for that. 5.1, using fundamental identities. In trigonometry, we got 50 points here of classwork, and you got only 2 points here of classwork today. Teachers, your bell work for today. And these exercises here, sketch the graph of the function here. Include 2 full periods. So include 2 periods of graphing here for this one and that one for your students. Students, you have 6 minutes to do that. Okay, welcome back for our solutions here today for graphing these trigonometric functions here. So for 2 pi over pi period 1, you have 2 pi over pi would equal 2 here for that. And then the amplitude will be 1/2. So the way that graph would look, it would look like this here, where it goes through your origin, and its min is here at your negative 1/2, and then your positive 1/2, and then you have a period here of 2. So this would be your period between these 2 minimums here. And then down here you have another function with a period of 2, and it's a tan function, so it's going to look like this here. So this would be negative 1, and then this will be positive 1, and then your function will look like the graph. Okay, so moving on into our lesson today. On occasion, factoring or simplifying can best be done by first rewriting the expressions of just one trig function, or in terms of sine or cosine alone. So sometimes just to convert over into sine or cosine. And we'll get into these strategies in example 4 and 5. This goes in your notebook, students, so put this in your notebook. We go into our next example here, example 4, factoring a trigonometric expression. So we have factoring cosecant squared x minus cotan x minus 3. So we're going to use this identity here. Cosecant squared is the same thing as 1 plus cotan squared x. So we're going to put that, substitute that in there. And so when we do that, we have cosecant squared x minus cotan x minus 3 will equal 1 plus cotan squared x, which is this substitution here for that expression, minus cotan x minus 3. So now we have by using a Pythagorean identity, we can use this substitution now. Now everything is in cotan. So when we combine our like terms now, we could have cotan squared x minus cotan x minus 2. We combine our constants here to get minus 2. And now when we factor out, we can factor out a cotan x minus 2. When we factor that expression now, we get cotan x minus 2 times the quantity cotan x plus 1. So we will get that when we factor that down. So let's go into an example here of guided practice of using that same technique for sine to the 4th power x minus cosine to the 4th power x. Down here, students, this is yours. So let's pay attention to this. Factor the expression and use the fundamental identities to simplify. And we'll use a graphing calculator to check it. So when we have this here, we can factor this into these 2 binomials here, sine squared x plus cosine squared x. We have a difference of a square here is what we have. So we have a factoring pattern that we can apply here. And then this will be the same thing as 1. This equals 1, so this becomes 1 times our sine squared x minus cosine squared x, which equals sine squared x minus cosine squared x. And then you can use your graphing calculator to check that. I guess, students, I'm going to go ahead and extend myself for this. Here, secant squared x plus tan squared x, so secant squared x plus tan squared x times secant squared x minus tan squared x equals the secant squared x plus tan squared x. So if we break this down into these two binomials, this will become 1, and then rather this will become 1 here, and then we have 1 multiplying by secant squared x plus tan. So that'll be the way that you can reduce those down to simplify those trigonometric expressions. Let's get into another example here, sine t plus cotan t cosine t. So begin by rewriting cotan t in terms of sine and cosine. So we can get sine t plus cotan t cosine t will be the same thing here as sine t plus cosine t over sine t times cosine t. So cotan t becomes this here. We have a quotient identity here from that. So now we can add our fractions now together, and we can make our common denominator here, sine t. This will become sine squared t plus cosine squared t. And then by simplifying further, we get 1 over sine t by using a Pythagorean identity. And then this will equal, this is the same thing, 1 over sine t is cosecant t, would be the reciprocal identity which this represents there. So let's get into another example here. Let's simplify this expression, and then students, this is yours down here. So how can we simplify that? The way we can do it is we can combine tan x by making a common denominator here of tan x. This becomes tan squared x minus secant squared x over tan x will equal negative 1 over tan x, because this will become negative 1 up here as an identity. Negative 1 over over tan x, which will equal the negative cotan x. So this is an equal expression to negative 1 here. And then down here, I do this for you. Pay attention here. Cosine squared x plus 1 plus 2 sine x plus sine squared x. By using our common denominator here, by multiplying 1 plus sine x times cosine x. Then we get this in our numerator, and then we combine like terms up here, 2 plus 2 sine x. So 2 plus 2 sine x. This will become 1, and then we add 1 to that, and we get 2 plus 2 sine x over this denominator. And then we do some canceling here, and we get 2 over cosine x, which is the same thing here as 2 times secant x. So by factoring out a 2, this would become 1 plus sine x, and then that will cancel. And then we're left with 2 up here in the numerator. 2 over cosine x will simplify into 2 secant x. Okay, into another example here. Rewriting a trigonometric expression, rewrite 1 over 1 plus sine x so that it is not in fractional form. From the Pythagorean identity, we get cosine squared x equals 1 minus sine squared x will equal 1 minus sine x to 1 plus sine x. So we know this is equal to cosine squared x here, 1 minus sine squared x. So by multiplying both numerator and denominator by 1 minus sine x, we'll produce a monomial denominator. So by doing that, we multiply 1 plus sine x times 1 minus sine x over 1 minus sine x, which is 1. We can use our identity property of multiplication to do that. Then once we do that, we end up with this here, 1 minus sine x over 1 minus sine squared x, which is the same thing as cosine squared x in our denominator. So we have 1 minus sine x over cosine squared x. And then 1 over cosine squared x minus sine x over cosine squared x. We separate our numerator like that. And then now we can write this as a separate fraction now. 1 over cosine squared x minus sine x over cosine x times 1 over cosine x, which will now become, this will become secant squared x minus sine over cosine is tan x, and then 1 over cosine x will be secant x. So it will simplify into this expression, eliminating all of our denominators. And that's by using the reciprocal and quotient properties here of trigonometric expressions. So let's try one now in our guided practice. Sine squared y over 1 minus cosine y. And I'll probably do this one too, so students, pay attention. So sine squared y is the same thing as 1 minus cosine squared y over 1 minus cosine y. And then 1 minus cosine y, when we factor this down here, 1 minus cosine squared y is the same thing as 1 plus cosine y times the quantity 1 minus cosine y, and these will cancel. So we're left with 1 plus cosine y over 1 for this one here. Down there, I guess you got to do that one, not all your lucky day. So our next example, trigonometric substitution. Let's use the substitution x equals 2 tan theta, for theta being greater than 0 and then less than pi over 2, to write the radical 4 plus x squared as a trigonometric function of theta. So begin by letting x equals 2 tan theta up here in this expression here. Then you can obtain this situation here, 4 plus x squared radical equals radical 4 plus 2 tan theta squared. So there's our substitution. And then when we do our squaring here, we end up with 4 times quantity 1 plus tan squared theta, using our distributive property here, of 4 times this situation here. Once we multiply that out, and then we get 4 times secant squared theta using our Pythagorean identity, and we end up with 2 secant theta by taking the square root of 4 secant squared theta, and then secant theta is greater than 0 for 0 less than theta, theta less than pi over 2. Let's try one now. So we have the same range here for our function, 0 less than theta, theta less than pi over 2, for this expression here by substituting 5 sine theta for x. So once we do that, we have 25 minus 5 sine theta squared. And then once we do our squaring, this becomes 25 sine squared theta, 25 minus 25. And then once we factor out, we have 25 times 1 minus sine squared theta. And then this becomes cosine squared theta, 25 times cosine squared theta. Then when we take a radical of this, the square root of that, we end up with 5 cosine theta. And then down here, kind of like the same thing here, 64 minus 16 times 4 cosine squared theta. And then we can factor out an 8 out of here. And we get 1 minus cosine squared theta, because this will become 8 minus 16, 4 cosine squared theta. And then once we take the square root of all of these here, we end up with an outside radical 8 times 1 minus cosine squared theta, which when we take the square root of this, just becomes sine theta. So we end up with 8 sine theta for number 80. And that is your 5.1 Part 2 pre-calculus lesson. Email me here for other materials and questions. Thank you very much.